Broadcasting the solutions to lab 4.1. Actually, I'm going to go over the pre-lab notes because I feel like they're fairly important. And in the pre-lab notes, we first distinguish the first three main factors that can increase the rate of a reaction. And we talked about those as concentration. And if you recall, we're always going to put the concentration of something in brackets. We talked about temperature. And we talked about surface area. And we said that all three of these have a very similar looking energy diagram in terms of their effects, in that none of them change the energy of activation, the E sub A. So if we have energy and time here, all of them basically their job is to push the reactants up the energy hill. So they push up EA. That's really their function. As opposed to the last one, that was the catalyst. It's got a different mechanism. This is really the important one to focus on, and I did mention this will probably be your multiple choice question on the exam. A catalyst really serves to drop the energy of activation. But notice it did not affect where you start or where you end. So delta H is constant. But we notice that's the catalyzed reaction. So the catalyst drops E sub A. It's really its function. Oops. We got something going on here. Who is that little guy? Anyways, let's ignore. Ooh, what are you doing? Let's ignore that and just go on. Pretend it's not there. So the catalyst drops E sub A. Now in this lab 4.1, I'm not going to be going over the data. I actually don't have the PDF of that. But we did see that we looked at concentration, we looked at temperature, and we looked at the effects of a catalyst. So let's go on to the questions, the main part that we just want to make sure you guys have a firm understanding on. Okay, so the first question asks, what effect does concentration have? Compare columns 1 through 5. So concentration increased the reaction rate. I know this because as the amount of water decreased from as the amount of water increased from 0 milliliters to, I believe the last one was 4 milliliters, the reaction took longer. Okay? So we're seeing that as the amount of water increases, and increasing the amount of water is really going to be decreasing the concentration. So as concentration increases, the reaction rate also increases. I know this because as the amount of H2O increased from 0 milliliters to 4 milliliters, the reaction took longer. And if it takes longer, we know that that's the same thing as saying the rate is going down. What do you think the mechanism behind your answer is? So when I say mechanism, I mean what's going on a molecular level. So simply, we could say that increasing concentration by decreasing H2O present decreased the amount of space reactant molecules had available, and thus increased collisions. SP question mark. I'm not sure if I spelled that correctly. All right, number 2. What effect does temperature have on the reaction rate? Okay, so you say, we could simply say in this one that as we increase temperature, we increased reaction rate. Okay. The well with the hot water, or actually that was the hot KiO3, took less time to react. So I know it's a little counterintuitive, but less time, okay, means a faster rate. I know in physics you guys often talk about rate as described as the change in position over time. And if you decrease t, you increase rate. Okay, these are inversely related to one another. What do you think the mechanism behind your answer is? Okay, so as you increase temperature, reactant molecules are moving faster, and thus have a greater chance of colliding. It's all about collisions. 5. What effect does the catalyst have on the reaction rate? Okay. Addition of catalyst increases reaction rate. Okay. The well with H2SO4 added, okay, and that was the catalyst. Took less time to react. What is the mechanism? This one's a very important one. Okay, so a catalyst takes reactants on new path to product, and I think it's really important that you understand that the reactant is being converted to the product. We're not changing where we start or where we end, okay? But it took it on a new path with a lower energy of activation. So if you reflect on our diagram, there's reactant, there's product. Okay, the catalyzed pathway is just going to have a lower energy required, so the reaction is happening at a faster rate. Take care, guys. Have a good day.